I'm Harith bin Aimiros, and we are from Group 4 from EH243 and this is our video presentation for Gas Absorption Refrigeration System for Reservoir and Gas Laboratory, CGE 617. For the introduction, I will be introducing this topic regarding case study for thermal engineering, the study of the usage of gas absorption refrigeration system in study of thermal engineering. The research focusing on utilization of engine exhaust gas as the energy source. Nowadays, waste energy recovery rise in popularity due to the nature of the cost reduction of the system and focusing on the exhaust gas as the energy source due to the increasing amount of vehicle use. For this case study, NH3 solution used as the refrigerant and the impact of the ARS or Absorption Refrigeration System on an engine performance and exhaust gas emission. This absorption refrigeration system enable for energy saving because they can use the heat energy to produce cooling instead of electricity used by conventional vapor compression chillers. Nowadays, absorption system is become more popular in many industries due to the increasing of costs and the environmental impact of generating electricity. Back to the case study, the heat comes from both the heater and the exhaust gas supplied to the cooling system can be controlled based on the release of the exhaust gas and the usage of the heater, and hence the impact of usage. The usage can be observed to the refrigeration system.
Hi, I am Shazaatul Shuhadha. So I am going to explain about the theory part of the gas absorption refrigeration system. Okay, so similar with vapor compression system, but here we replace the compressor with the absorber. So in the vapor absorption system, we use the ammonia water solution that will run throughout the system, whereby the ammonia will act as the refrigerant that gives cooling effect, and water will act as the absorbent. So now let's look into the major part and components of the system. So firstly, we have evaporator. So here the refrigerant effect or cooling effect will take place. Next we have absorber, and then pump, which is placed beside the absorber. We have generator with an analyzer that fits on top of it, and then condenser, and lastly we have the expansion valve. So all of these components are connected with the connecting pipes, and these major components together will construct the vapor absorption refrigeration system. So let's start with the evaporator. The cold and low pressure ammonia coming out of the expansion valve will go to the evaporator. We know that all of the cooling activities will take place at the evaporator. So this cold and low pressure ammonia liquid will enter this evaporator and absorb all the heat from the surrounding of the evaporator. So by absorbing all the heat from the surface of the evaporator coil, the liquid ammonia will turn to vapor. After that, this low pressure ammonia vapor will enter the absorber, whereby in the absorber there is already contained weak ammonia water solution. So when this ammonia vapor enters the absorber, the water will absorb ammonia vapor. When this weak ammonia water solution will gradually become strong solution. The more ammonia vapor entering the absorber, the stronger the solution will become. So when water absorbs ammonia vapor, it also liberates heat that will increase the temperature of the solution. So when the solution becomes hot, gradually the capacity of the water to absorb ammonia is also decreases. So to keep the temperature of the solution to an optimum level, a supply of cool water is provided through this pipe. So this external pipe of cool water carries over heat from the solution, and thus water can be continuously absorbed incoming vapor. Beside the absorber, there is a pump. So this pump will transfer this strong ammonia water solution into the generator. Heat is is applied to this generator by external heat. When the ammonia water solution enters the generator, it will be heated and turns into vapor. And then there is an analyzer at the top of the generator which will allow only ammonia vapor to pass through it. This analyzer will continue condense the water vapor and send the water back to the generator and transfer the water or V solution into the absorber. This is because if water vapor enter the system, it decreases the efficiency of the refrigeration system, and if a larger volume of water enter the system, it can damage the system. Next, the high temperature, high pressure ammonia vapor will enter the condenser. So when this ammonia vapor enter the cold condenser, here it will absorb the heat from the ammonia and completely convert it into liquid. This condenser can be cooled by water or air or other substances from the external sources, which will liberate heat coming to the condenser. Liquid ammonia that coming out of the condenser will pass through this expansion valve, whereby the high pressure of liquid ammonia will be expanded inside this expansion valve. So we know that when expansion occurs, the pressure between the molecules decreases and thus the temperature will fall. So we get a low pressure, low temperature of liquid ammonia and coming out of the expansion valve. Then this liquid ammonia will be passes over to the evaporator by connecting pipe, and this whole cycle will be repeated over and over again. Thus, refrigeration or cooling will occur continuously. So this is how the water vapor absorption refrigeration system works.
So as for the applications, the main industries that require refrigeration unit or cooling systems are industries such as district cooling, electricity production, chemical and petrochemicals, pharmaceuticals, and food and beverages. The concept of district cooling is based around the generation of cooling streams, mainly chilled water, with different technologies in a central plant. It is then distributed to different populated places like homes, offices, venues, or other residential or commercial projects. By centralizing the cooling production, a higher efficiency is achieved. There are some advantages of district cooling, such as district cooling has a reduction in capital, operation, and maintenance costs with respect to individual cooling system. Next, combined with energy storage system, a considerable reduction in peak electricity demand can be achieved. District cooling also provides the important economic and environmental benefits to residential communities and tourist areas. So next is electricity production. Electricity generation is often based on the combustion of different fuels. To achieve a higher efficiency, inlet air must be in determined conditions. Other parts of production and distribution systems like electric generators or distribution plants also generate heat when operating. To minimize maintenance operation, refrigeration systems are necessary. That being said, this refrigeration equipment is usually based on compression or absorption cycles. In chemical and petrochemical industries, control of temperature is an important factor in reaching high efficiency in their transformations. Distillations, crystallizations, or condensations are operation requiring the removal of heat. Hence, refrigeration systems are necessary to obtain their products. In chemical and petrochemical industries, large-scale cooling plants are used in their processes. Due to high flow required and the location of the industries, river water or seawater is used as refrigerant. Compression cycles and absorption cycles are also used to cool down the hot stream after the heat has been dissipated in the different operation. Moreover, since hot streams are also required in other parts of the process, heat exchangers are usually applied to heat these streams and maximize the efficiency of the operation. Last but not least, food and beverages industry. So maintaining the cold chain in the food and beverages industry is vital for preserving products and avoiding possible microbiological contamination. Each product has its own optimal conditions for storage and preservation. In the preparation process, temperature is one of the most important parameters to assure food safety. In products like fish, poultry, meat, dairies, or fruits, refrigeration systems are necessary to keep products in low temperatures and extend the recommended consumption period. Other types of food and beverages industry like brewery require several refrigeration systems to finish the biological and chemical reactions that take place during the process and to preserve the optimal conditions of the product once the process is finished. Hence, in the food and beverages industry, several refrigeration systems can be used. If the cooling system is necessary during processing, the most typical refrigeration system is the use of chilled water. There are other refrigerants that can be used instead of water, but it is important to avoid chemical contamination in case of spillage. Thus, water is the most recommended refrigerant to be used in this industry. However, when the product is finished and packed, temperatures below 0 degrees Celsius are necessary, so other systems like compression or absorption cycles may be used. These systems use other refrigerants besides water, with better characteristics such as high latent heat or absorption capacity to get lower temperatures that freeze the product. Last but not the pharmaceutical industry is based around operations where fulfillment of strict conditions is essential for the success of every process. Going further, many production procedures imply biological or biochemical reactions that only take place in strict conditions in which microbiological species generate chemical compounds at their maximum yield. It is important that pharmaceutical firms develop their products in clean, disinfected rooms. So one of the most important parameters in this industry is temperature. Hence, strains used for drug or medicine production are stored in very controlled conditions, usually at low temperatures. So, for these reasons, the pharmaceutical industry must rely on highly sophisticated refrigeration systems that permit the temperature adjustment of rooms and storage units to extremely precise temperatures. For pharmaceuticals, the size of cooling plants tends to be smaller since the production capacity of pharmaceutical industry equipment is limited. Hence, this industry utilizes a central cooling plant with transformer stations and refrigerants that are distributed through the different clean rooms of the factory. Other refrigeration systems that can be found in this industry are oxychlorination plants, ammonia cooling or oxygen liquefaction plants, or compressed air cooling.
Bismillahirrahmanirrahim and Assalamualaikum to all. My name is Muhammad Raziq bin Roslan and I am from Group 4. So the chosen case study for our video presentation is the usage of gas absorption refrigeration in thermal engineering. So I am responsible to explain the advantages, the disadvantages and the innovation or improvement that can be made in this system. First of all, I would like to present the advantages of the system. The first advantages, in my opinion, is the efficient and optimal energy consumption, which means this system offer a lot better performance and offer less heat loss during the operation. Next is also promotes the environmental friendly of the workplace. As it say, the alternative will use the heat loss during the operation to reduce the emission of carbon dioxide, which can be helpful in the environment. Next, advantages is the alternative as simple and compact installation if the venue of installation have all the proper area and no other equipment between them. Last but not least is it has low maintenance cost compared to other alternative as it can use different heat sources in order to operate. Next, the disadvantages. This disadvantages is why why the many reason of the people will already choose under alternative. However, I would like to present my own opinion. The advantages of the system outweigh the disadvantages of the system. But I would like I would also like to present the advantages to give a additional information about the system. Okay, the system require high usage of electricity, which can be said to all system in heavy industries such as oil and gas and heavy metals. Next is require large space to be installed. As I said before in the advantages section, the installation require an empty and vast and proper venue to ensure the installation will be done without an hinge. Next, if there is no other alternative places or venue for the installation, therefore a support structure is needed to install the system. Last, large cooling tower need to be installed. This is considered disadvantageous because the size may greater or exceed 1/3 the size of electric boiler, which can be very large in comparison. Last but not least, I would like to present the innovation or improvement that can be made or have been made in the system to provide better costing and maintenance costs by using the alternative. First of all, the usage of renewable energy and its sources. The renewable energy can be solar energy, biomass, and also geothermal. If the usages of the said material I said before can be implement, the costing for the system may be lesser even further than before. Next, the research has been done that if the hydrogen can be the usage of hydrogen can be changed into helium, it will cause the increase of COP, which is the acronym for coefficient of performance. The higher the COP, the better the operation will be. Okay, next, but last and not least, the variety of absorption refrigeration system in the industry. Uh, so far as I know, there are three different system which are simple water and salt system. Second is water spray absorption refrigeration system, and last but not least is the single pressure system. All the three system use different method. However, it's still an absorption refrigeration system to cool a substance or something. Uh, That's all for me. Thank you.